it's Zach, and today we're talking about wires, cables, and conduits. So enjoy, and don't forget to like, comment, and subscribe. A wire is a component that transfers current from one place to another. It consists of a conductor, usually made of copper, and an insulator that surrounds the conductor. The conductor transmits the current, while the insulator confines the current to the conductor and prevents it from spreading to unwanted areas. Wires have two common types of conductor structures, solid and stranded. A solid wire consists of a single conductor around an insulator, while a stranded wire consists of many conductive strands twisted together. Solid wires are useful for wiring breadboards because the ends slip easily into the breadboard sockets and will not fray in the process. They are also good for building wiring construction. However, stranded wires are more flexible and less prone to breakage. This means that large industrial wires have to be stranded because solid wires in large sizes are too stiff to handle. We've talked about wire structure, now let's talk about wire sizes. Wire diameter is measured in mils. 1 mil is equal to 1/1000th of an inch. The cross-sectional area of the wire is equal to the diameter of the wire squared and is measured in C-mils. For example, a wire with a diameter of 3 mils has a cross-sectional area of 9 C-mils. However, while it is good to know that wire size is measured in C-mils, commonly used sizes of wire have been assigned a number within a system called the American Wire Gauge, or AWG. Wire sizes go from 40 AWG to 4/0 AWG, and stranded wire may have the same AWG number but different strand count. The AWG numbering system is unique because the larger the number, the smaller the wire actually is. For example, a wire that is 30 AWG is smaller than a wire that is 10 AWG. Now let us develop an idea of when each wire size should be used. Wire sizes from 40 AWG to 20 AWG are mostly used in manufacturing electrical equipment. Wire sizes from 18 AWG to 16 AWG are used for flexible cords, signal systems, and other purposes where small currents are involved. 14 AWG to 4/0 AWG are used in residential wiring as well as in commercial and industrial wiring. Wires have certain characteristics based on their size. All wires provide a resistance to current. This resistance is measured in ohms per 1,000 feet of wire. When the wire size increases, the amount of resistance the wire produces decreases because electrons have a larger area to flow through. Current flowing through a wire causes heat. There is a limit to how much heat a wire can handle before it becomes damaged or even catches on fire. The maximum amount of continuous current a wire can handle before experiencing heat damage is called its ampacity. In general, larger wires can handle more continuous current and therefore have a larger ampacity. However, the type of wire insulation as well as the wire's operating environment also affect the wire's ampacity. Now that we have discussed wire characteristics, we should briefly discuss voltage drops. Ohm's law states that voltage equals current times resistance. Per this equation, there is a voltage loss when current goes through a wire. It is important for the engineer to be aware of this because if voltage drop isn't factored into the design, equipment won't operate as well as it should. For example, if an electric motor is operated on a voltage 5% below its rated voltage, because of voltage drop, its power output drops almost 10%. Voltage drop, however, is not a safety hazard. For many purposes, it is desirable to have 2 or more wires grouped together in the form of a cable. Now onto a quick note. This video will discuss common cable types used in power distribution. Cables used in electrical communication, such as coaxial or fiber optic cables, will be discussed in a future video. The first type of cable I would like to discuss is nonmetallic sheathed cable, also known as NM cable. NM cable costs less than other cables, is lightweight, and easy to install. This means that it is ideal for residential and light commercial wiring. However, if a more durable cable is required, such as in more intensive commercial or industrial wiring applications, metal-clad or MC cable should be used. Its metal sheathing causes it to be less prone to damage than NM cable, but it also causes it to be more expensive and more difficult to handle. Sometimes it is ideal or even required for wires and cables to be placed inside a raceway. A raceway is an enclosed channel of metallic or non-metallic material designed specifically for holding wires and cables. Heavier walled raceways are called conduit, while thinner walled raceways are called tubing. The next part of this video will discuss commonly used raceways. Rigid metal conduit, also known as RMC, is thick-walled, durable conduit typically used outdoors because of its resilience. However, it is difficult to handle. Therefore, electrical metal tubing, also known as EMT, is used indoors because while it is less durable, it is easier to handle and is lighter. If wiring and cables need to travel underground, rigid polyvinyl chloride, also known as PVC, is recommended because it resists corrosion. However, it is not recommended for use above ground as direct exposure to sunlight can degrade the material over time. If you need to run wire or cable through your house and without cutting into the walls, then channel raceway is the way to go. It runs across the surface of walls, allowing wires to go to different locations without being noticed and provides some protection. If you need the conduit to bend, such as for a short run between a wall box or a fixed appliance, such as a garbage disposal, then flexible metal conduit, also known as flex, is ideal. If you need the conduit to bend outdoors, then liquid-tight flexible metal conduit, also known as LFMC, would be the recommended conduit choice. Now onto another quick note before finishing the video. It may be confusing to keep track of when to use certain wires and cables. The good news is that the United States has something called the National Electrical Code, also known as the NEC. This code details specific rules for installing electrical materials such as wiring. It ensures that the finished job will be electrically safe. If you follow the NEC, it is less likely you will install the wrong type of wire or cable. In summary, we have talked about wire types, their characteristics, their sizes, common cable types, and common raceway types.